Hello everyone. In today's lecture, we have to discuss another concept of the steady state stability of that power system stability concept, that is the effect of inertia. Okay, so in the previous lecture, we had discussed the Clark diagram with losses and the without losses concept is there. The Clark diagram is generally used to finding out the steady state stability limit by using the graphical representation with by considering the losses parameter and without losses parameter. That is really but with resistance and the without resistance connection between the two machine systems. So in this lecture, we will discuss the effect of inertia on the two machine system, that is nothing but with losses condition is there. Okay, while we have to discuss the two machine system with losses condition that we already discussed in the our previous lecture, that the two machine system, that is nothing but the machine one and the machine two, are that should be connected with the resistance and the inductance in between them. Okay, and the two machine system are generally used to provide the power from the one end to the another end, or from the another end to the previous end. Okay, so let us consider there is a different effect of inertia. Here we have to consider the different cases of that inertia, that is a different finite inertia, or the infinite inertia, or the equal inertia, or on the infinite bus of the series reactance and the reactance and the resistance. Okay, so of the two machine system with a losses condition. So let us consider the generator of the finite inertia feeding the power to the infinite bus through the series impedance with a resistance. Means what? One that two machine system should be there. That is that but the two machine system should be connected. In between that, the resistance and the inductance resistance and the JIX one machine, and that is ready, but the two machine are must be there that should be connected to the infinite bus. You get P1 power or you get P2 power. Okay, so the power angle for the curve for the constant excitations, that is a depend the power angle curve that shows you in the figure 1. Okay, so from the figure 1, we have to observe that the output of that generator, that is ready but this is ready but the power angle curve of the two machine system with the losses condition, where the P1 is ready but the power should be transferred from the one generator to the another one to the infinite bus, and the P2 it should be ready but the power should be injected drawn from that infinite bus, that is ready but the machine 2, that is ready but the two machine system, and the resistance and the inductance that should be ready but the impedance of the transmission line with the considering study but the with losses condition. Here the resistance are used, that's why with losses parameter condition are must be used. Okay, so here the power angle curve of the two machine system with the losses through the series resistance and the reactance are shown in the figure, where the P1 is that but the generator one and the P2 is that but the that is a motor load is there. Okay, so he just drawn the power, that's why their direction should is toward the infinite bus, and that but the inverse the infinite bus. Okay, and that the P1 is ready but the output power of the generator 1, and the P2 is ready but the output power of that generator, that is a generator 2, that is and the P1 that is del M1 is ready but the maximum load angle of that P1 that should be injected to the circuit, that it should be the is ready but the more than 90, that is ready but the, and whereas del M2 is ready but the less than 90. Okay, so the output of the generator is ready but the P1, and the output received with the infinite base is ready but the minus P2. For this reverse direction, that's why it's considered ready but the negative power. Okay, so if the power input to the generator slowly increase, okay, power input to the generator it should slowly increase, the generator voltage in the phase should be increased, thus increasing the angle separation del M. Means what? Agar power should be increased, P should be increased, automatically that del should be also increased, and the voltage should be also increased. Is it that? Thus the output of the generator is increased so that equal to the infinite, equal to the input until P1 should be reaches to its maximum value. Where it is nothing but the maximum value, that del is equal to del PM is equal to the 180 minus theta 12, it should be the less than 90 degree. Therefore, the system should be stable for all the positive value del than less than del Means what? First, we have to increase the power. increase the power, increase the voltage, obviously there is a but the power should be increased. Voltage increase करोगे then the power increase होगा, power increase होगा तो del increase होगा, del increase हो गया it should reaches कहाँ तक होगा, del m1 तक, del m से less than, so that for the stable condition that del it should be is nothing but the is equal to the del m1, del m1, that is nothing but the del m1. Okay, it's nothing but what is the value of that, it's nothing but the 180 minus theta minus that is theta 12 minus 180, that is 180 minus theta 12, it should always less than 90. Therefore for the system it should be the stable condition, the positive value of del should be that del should be always for the stability condition del should be always less than 90 degree. It's nothing but the very important condition, it should be always less than 90 degree. Okay, now the second condition. Okay, now the how we are, if the maximum value of power is received by the infinite bus at del is equal to del m2, first condition tha del p1 where del is nothing but the del m is nothing but the del 180 minus 180 minus del m1. Okay, so now the del m2, that is nothing but the maximum power is received by the infinite bus at del m2, that is nothing but the p2, it should be the power received to the from the infinite bus. It just that's why it's nothing but the negative power, that's why uska del m2 kitna hai, del m2 is just we are observing is nothing but the less than 90 degree. Okay, so the del is equal to del m2 is nothing but the theta 12 is less than 90 degree, but it's nothing but the also less than del m1. Therefore, for the definition, the steady state stability limit is maximum value of the received power which occur at a del is equal to del m2. Means what? We are getting the maximum power from the infinite bus at a p2 is nothing but the at the angle of del m2, which is nothing but less than 90 degree. Okay, so this is the condition for the that is nothing but the finite inertia system. Okay, ये finite inertia के लिए हो गया. अगर finite inertia means what? The finite inertia is that the synchronization between the load and the generator, it should be the same. Now consider the inertia of the finite inertia receiving the power from the infinite bus. Means what? Receiving from the infinite bus through the series impedance. Means what? यहाँ पे क्या condition था? Feeding the power to the infinite bus. Here receiving the power from the infinite, here feeding the power, that's why we're steady state feeding कर रहे means what, p1 is should be the feeding and the p2 is ready but the receiving. यहाँ पे क्या हो गया, totally reverse, totally reverse one, p1 is ready but the output and the p2 is ready but the input, means what, reverse direction में flow right, that's why that's ready but what, this is the finite inertia receiving power from the infinite bus, means what, p1 is nothing but what, p1 is nothing but the output and the p2 is nothing but what, is the input. रिवर्स डायरेक्शन में पावर फ्लो हो रहा है, दैट्स व्हाई द P1 is nothing but the output and the P2 is nothing but the input to the motor. So let the shaft load on the motor slowly increase. शाफ्ट लोड ऑन द, अगर मोटर लोड जो भी शाफ्ट लोड है ऑन द मोटर इसको अपन इंक्रीज करेंगे. इफ द लोड शुड बी इंक्रीज ऑटोमेटिकली दैट वोल्टेज इज रेडी बट डिक्रीज रिटार्ड्स इन द फेज. अगर वोल्टेज डिक्रीज हुआ दस इंक्रीजिंग द डेल, डेल इंक्रीज होगा, डेल इंक्रीज हो गया तो ऑटोमेटिकली इनपुट ऑफ द मोटर इट शुड बी इंक्रीज. ये इनपुट ऑफ द मोटर शुड बी इंक्रीज it so that it should be equal to its output to maintain their synchronization until the P2 should reaches their maximum value. What is ready but the maximum value of that P2? P2 is ready but the maximum at a del M2. Okay, that's why that's ready but the del M2. If the load is further increase, agar load agar further increase hoga तो automatically the synchronization should be the lost. That's why that for the infinite bus, that for the finite we are getting the power from the infinite inertia receiving power from the infinite bus through the series impedance where the P1 is ready but the output and the P2 is ready but the input. Here we are providing let the load should be on the motor should be increased. If the load increase automatically voltage retard del increase होगा input power increase होगा, input voltage input to the motor distributed but the voltage should be increased and it should be equal to the output until the P2 should reaches to the maximum value of that del M 2. Okay, so if the load motor is further increased, the synchronization should be lost, and we are not getting the maximum power from the infinite bus. Okay, so in the both the preceding case of that stability limit is the maximum value of that P2 which occurs at the del M2 is equal to theta 1 2, which is always less than 90 degrees. So that from the above two cases we can conclude that the for the equal inertia case or the for the finite inertia case we are getting the maximum value of that power, that is P2, which is occurred at the all theta M2 बोलो या फिर theta that is del M2 बोलो या फिर theta 1 2 बोलो, it's always less than 90 degree for the stability point of view. Okay. Okay, so now the so in that case the finite motor synchronization, if it is lost, if the finite motor synchronization is lost, if del should be increase the angle, कौन सा angle del m2 का, if it is that del should be increased, that is study but the del m2 should be increased than 90 degree, then what happen, the synchronization should be, synchronization क्या हो रहा है, synchronization should be lost, synchronization lost in this condition if the del is exceeds this angle. But in the case of the finite generator, del can increase from the del m2 to the del m1, which is accompanying the increasing the generator output P1 before the synchronization is lost. Thus the generator is more stable when the operating at a stability limit than the motor is. So the generator is nothing but the more stability is working on the more load angle as compared to the motor point of view. Okay, so let us consider the third case where the generator and the motor both are working on the finite and not necessarily equal inertia. Means what? Both are working on the finite inertia, but not should be their inertia should be the equal. So in that case, what happen? P1 का inertia अलग रहेगा generator का और P2 का inertia अलग रहेगा. So what in that case, it should be expected that the maximum stable value of that del must be greater than del m2 but should be less than, means what, क्या range रहना चाहिए, it should be must be greater than of del and it should be always less than value of that del m1, and that is exact value would be depend upon the relative inertia of that two machines beginning near to the del m2 if the inertia is greater, if the inertia of the generator will be high compared to that motor near the m2 if the reverse will be true. So this is the condition of that load angle for the stability point of view where we are this is the load angle range for which we are getting the stability point of view of the stable point of view if the inertia of the motor should be the finite one and not should be the equal one. So in that case, the equivalent power angle curve of the two machine system should be the derived having the maximum value of del. So it's nothing but the del is equal to del C, that is the critical angle. It should be the tan inverse of the moment of inertia m1 plus m2 upon m1 minus m2 into the tan of theta 1 2, whereas m1 and the m2 are the study by the inertia constant of the two machines, and the critical angle, that is del C, is study always between the angle of theta 1 2 180 minus theta 1 2. So it approaches the del m2 if the moment of inertia of the machine 1, it should be the more than equal to the it's far more than is greater than m2, and it approaches the m1 if the m1 is less than m2, means what, it reaches approaches to the m1 2, means what, the critical angle of that del, it should be reaches to that del m2 if the moment of inertia of motor 1 or the machine 1 it's greater than m2 machine 2 or vice versa. So this is nothing but the value of that load angle for the equal inertia consisting having the three cases: finite inertia and the infinite inertia, and the for the finite inertia, sorry, equal inertia and the non-equal inertia, and for the infinite burst for the P1 and the P2 machine system. So in the next lecture, we will discuss the another concept of that power system stability of that steady state stability concept. Thank you so much. So in in each of these three cases considered above, all we are positive series reactants, and thus we are the steady state stability is reached as del is equal to del m2. So it does, however, it appears that del can be increases beyond del m2 up to the value of del c before the synchronization loss. Thus, the maximum received power, that is nothing but the margin of the stability which depend upon the relative inertia being the greatest when the machine 2 is at infinite burst. When the machine 2 is nothing but what? Is a infinite burst. If machine 2 is nothing but the motor and the machine 1 is nothing but the generator case. We are getting the maximum power when the machine 2 is nothing but the motor case and the machine 1 is nothing but the generator case is there. Okay. So this is the condition for that equal inertia system. So in the next lecture, we will discuss the another concept of that, the stability. Thank you so much.